All right, welcome back, guys. I feel like we're finally making some progress on activity 16. This next section, we're going to be looking at 16.3, proving rhombuses, okay? Rhombus, a lot of y'all like to call them diamonds. Rhombus or rhombus, the way it's spelled, is the quadrilateral that is equilateral, meaning that all the sides are the same length, okay? Not the angles, the sides, okay? So we're talking about a rhombus. Again, some of y'all like to call it a diamond, but basically all the sides are going to be congruent. So if you see something called a rhombus, or if you see a drawing where they draw a quadrilateral and they mark all four sides the same, that is going to be a rhombus, okay? And so if it's a rhombus, all the things about a rhombus are true. All the things about a parallelogram plus all the things about a rhombus are going to be true, okay? So how do we prove rhombus given that we know something is a parallelogram? And that's really the key. Sometimes you're going to see questions that are like, hey, what's the best name for this quadrilateral? And at that point, you really have to research first, is it a parallelogram? And then is it a special parallelogram, rectangle, rhombus, or we'll look at squares here in a minute. But if we know it's a parallelogram, then all we need to do to prove it's a rhombus is we need one of these things. We need to prove, number one, that it's either equilateral, okay, so you could do distance formula 4 times to show that all of the sides have the same length. You can prove that the diagonals are perpendicular, and that's kind of special to a rhombus, the only parallelogram that has that particular trait, or a kite, okay, so diagonals are perpendicular on a kite as well, but that's not a parallelogram, so you don't need to worry about that. We'll get to that later. So diagonals are perpendicular, that would be slope formula twice, negative reciprocal slopes, reminder for perpendicular. And then the last one is diagonals bisect the opposite angles. That's going to be one that you see where they say, hey, what value would x would make this a rhombus? And you would plug in a value of x to show that the angle had been bisected, okay? And so you're going to see that in the practice as well. And we'll go over that here in a few minutes when I give you the answers to the questions. So these are the 3 ways you could prove it. Another thing to watch for in this section, just like you had with the rectangles, is they're going to ask you for that 4th point. Keep in mind this is a rhombus, so all the side lengths need to be the same length, okay, the same measure, all right? And so if you were given 3 points, don't draw a shape such that one of the sides is really long and one of the sides is short. That's not going to be the way the shape is drawn. Rhombus, they all have to be the same length, so that helps you to figure out where that 4th point is going to be, all right? So I'm going to give you, what do y'all want? I say 10 minutes. If you need a few more minutes, it's okay, but I think you'll go really 10 minutes. These go pretty quickly. You can use the book as a reference, or the PDF. Starting on page 230, it talks about rhombuses, and it kind of works through this idea. And then on page 232, they're going to give you some questions. We're going to look at questions 10 through 15 and come back to me in about 10 minutes or shorter if you're done quick, and I'll go over the answers with you, all right? Good luck, guys.